Hello, guys. So this is Josh again. Um, like I mentioned in my last video, I was going to post two videos about this problem. Um, this solution is actually already a stepstone in the direction of um, the evolution of this problem, which is the meeting rooms 2. But so this is kind of an overshoot for this type of thing, because this type of problem we could even solve it with a single variable. We don't need any type of complex data structures. But I'm still going to use it here just so we can kind of get the grasp of how what is it. All right. So let's go over the problem again. Right. So given an array of meeting times intervals consisting of start and end time, determine if a person could attend all meetings. So basically what you want to know is that if a meeting starts after the last one ends. That's it. Um, a question that you could make to your interviewer here, or you could raise this question here, which is that do the start and end time count? So for example, if you take this first example there, so starts at 0 and ends at 30. Does it mean that I'm already busy on start? And am I still busy on the 30? And the answer here is yes and no. So you are busy on the start, but you're not busy on the 30. So the 30 you're already free. So you're busy up until the 29 and 99. All right. So so in this case here, for example, we have another start at 5 and end at 10 and start at 15 and at 20. This one is easy because it's already sorted by start time. So we start at 0. This one we end at 30, but then we have another meeting at 5. But I haven't gone out at this one yet. So that means that no, I'm not going to be able to attend all meetings. And if we move on to the second example, so this one is starts at 7 and ends at 10. And we have another meeting starting at 2. It's weird, starting after the first one. And ends at 4. So this one, we can already kind of notice the first thing we need to do here, right? So the first thing I will do here is definitely sort by start time, because that's how we think about our calendar, right? If you look at your calendar, you're gonna start looking from like 9 a.m. or 8 a.m. whatever time you start working, and then you move forward, right? So this one starts at 2 and ends at 4. So, and then we have a meeting starting at 7 and ends at 3, at 10. So that means that, oh, this is true. So I can attend all meetings. So this is fine. So then, like we said, the first thing I'm going to do here is sort our interval times by start time. Then the second thing that we're going to do here is that we need to keep track of the last end time, right? So we started a meeting and we need to keep track of the end. So when we start the next one, we need to compare it with the last end time. And like I said, this is a bit of an overshoot, but we're going to use a heap here. We're going to use something called a priority queue, which basically is a list with an added functionality of a priority. So you basically return it. You can draw a priority queue using a heap, and it's basically a tree that has, in this case, that has the minimum priority on the top. So priority queue based on the end time. Because then we're always going to have the 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 smallest end time at the top, right? And then we're going to compare the priority queue and time with the current starting meeting. And for this, we're gonna loop over the intervals starting with the second one on the list. Why? Because here we're gonna create a priority queue and we're gonna add the first meeting to it. And four, so if a meeting on top of our priority queue ends after recruiting meeting is starting, return false. Right? And then we return false. And else we will pop whatever is on the top of our priority queue, because then the meeting is over, right? And then after that, we we'll just we will push the current meeting to our priority queue. And 7, return true after the loop. Right? So let's just take an example here. So for example, so we sorted this guy, right? And we create a priority queue based on this. And then we're going to compare. So we have this guy on a priority queue. We know that it ends at 4. So what we're going to do here is that is, and then we start the loop with this one, right? And then, oh, is 4 bigger than 7? No, it's not. Else, so then we're going to pop this guy because it's over. And then we're going to push this guy into a priority queue. And this is just a 2-item thing that we're going to get out of the loop, and then we're going to return true again. So this will work. An edge case that we haven't thought about it here is that, so if our intervals go 0, then we can go ahead and return true. Right? So here we need to sort, right? So intervals, don't sort. What we're sorting is kind of like a custom object. So we're sorting a list of a list. So we need to tell it, okay, what do you want to sort it by, right? So we want to sort it by a key. And to choose the key, we're gonna use lambda. So lambda 0. So we're picking the start time, right? Because we know that the first item in this little list here is the start time. Okay, so we done this. Oh, we need to create a priority queue now, or queue. So here, let's just call it like meetings happening. Just a list, okay. And then we need to we need to import this guy, heap cube. This is a library for Python that already knows how to deal with heaps. We don't need to implement this here. As long as you know kind of how it works, it's good enough. If you want to implement, you can find a dozen different algorithms on the internet to do that. So, and what we do here, we call heap queue dot heap. He's gonna give me something here. Yeah, push. And we want to give our heap, and we want to give intervals. We're pushing the first one based on the right. This is what we want to do. Okay, now we need to loop. Okay, so for meeting and intervals, starting with the first one. If our, oh, here, now we need to pop stuff, right? No, not really. No. Now we need to, now we're getting, we're not popping yet. So we're getting whatever's on the top of our heap. That's right. So we're getting meetings happening 0. If that is bigger than our current meeting start time, and we return false. If it's not, then we heap queue, heap pop. Yeah, if it's not, that means that it's the meeting is over. So we can get whatever's on the top from the list, and after this we call the heap queue again, heap push here, and meeting 1. Yeah, and here we return true. So let's give this a try. See, there's no errors. This is accepted. This is fine. You see that I already played around with this guy a lot. So this is good. And I guess that's it. I'm not really let's look for something here. So time complexity of heap queue. It's a binary heap with log and push and log and pop. Okay, so this is what I wanted to know. Yeah, so this is what I wanted to know. So this is log n. This is log n, this is log n. And this is basically O n. All right, so for time complexity here, I have O n log n. Yeah, because I could have all 3 log n, but then, yeah, then this is what I have here. And that's it. I hope you guys enjoyed this. See you next time.